So let's talk about how to calculate standard deviation. Team 3 had the following values for one of their team members in the 40 holes of golf. And you can see the values start at 10 and go up to 35. So we could calculate the range, right? The range of this data would be 35 minus 10. And we could also figure out the median and quartile 1 and quartile 3 and calculate the interquartile range. But I'm asking you to calculate the mean and standard deviation for the data set. So on our calculators, we're going to go ahead and enter these values in our stats editor. So I'm clicking stat and then edit. And I'm going to place these values in list 1. I've got a 10, a 12, 20, there's a 22, 2 26s, a 27, 28, 34, and 35. So you can see when I move back up here, my last value, my 10th value, is the number 35. And I can come back up to the top and just kind of quickly double check, but I've got 10, 12, 20, 22, 2 26s, a 27, a 28, a 34, and a 35. So my data is in there correctly. Now remember, standard deviation is us attempting to talk about consistency. How consistent is this particular person on their team? We know that they've got as close as 10 and as far away as 35, but can we quantify, is this a consistent person? So to calculate standard deviation, we're just going to go ahead and press stats again, go over to calculate, and we're going to select one variable, statistics. This is not bivariate data. We're not creating a scatter plot on it. It's not like when we were looking at, for example, square footage of a house and cost of a house, or I'm trying to think of another example, but that's one of them. This is just a single list of values, right? There's not an X and a Y. These are just values. So when I press this, my data is stored in list 1, and I'm just going to go down and hit calculate. So the values that I get, first thing is I see is this is X bar, and it's the mean of the data. So if I was to add all 10 values and divide by 10, I would get 24. The next one below that is the sum of my data, right? Capital Greek letter sigma. The sum of my x's is 240. If I was to square those values and add them, square them first and then add them up, it would give me 6,374. And then I've got here my standard deviation. This top one is based, the value I would use if this was based on a sample. The one below is if it's based on a population. In this case, I just had these 10 scores, so that's the population of all the scores that I had. It's not like I had a whole bunch of scores, like maybe I had, thousands and thousands of scores, and I randomly selected a small sample from that. I'm actually using all the data that was available, so this is based on a population. So this is the lowercase Greek letter sigma. It's kind of like an O that's trailing off this way, so sigma x, and the standard deviation is 7.8. Now, having the standard deviation by itself is not great. It's one of those things where you'd like to have others to compare it by. The smaller this number is, the more consistent it indicates that this particular person is. So if I had, under the same situation, if I had a standard deviation of 3, for example, I would say that person's very, very consistent. Now, another consideration is you could be, consistently off, right? You could be like getting very close to 100 centimeters away from the hole. So you're consistent, but are you consistent and as close to 0 as possible? The other thing that I like to look at is, you can see here n is the number of data points that I entered. If I go down, I can see the minimum, Q1, the median, Q3 and the max. Now the range, of course, is this distance between the minimum and the max. So 35 minus 10, this data set has a range of 25, and my interquartile range is 28 minus 20, which gives me 8, right? 28 minus 20 is 8. And notice 8 is fairly close to my standard deviation, right? The one thing we want to be concerned about is we don't typically use standard deviation to describe data sets that are not symmetrical or data sets with outliers, and that's because it affects what the mean is. And remember, we're trying to measure how far our data is from the mean value, so that's one consideration. But this should give you enough information to complete the rest of today's assignment.